Powerful, deadly.
The Gulf Coast and the ocean is just this beautiful mistress. She's a killer. She is a killer. Don't ever doubt it.
Hurricanes are a force that can't be ignored.
Everybody was boarding up. I was thinking, I don't know if I should stay here during the storm. I did start to get worried at the last minute when it really got crazy.
Predicting their path and their strength is paramount.
And you do not realize how terrifying those winds are until you sit there hour after hour and listen to that high-pitched howling.
Today we show you how tracking hurricanes has improved thanks to technology on the ground and in the air.
Eye on the Gulf, Hunting Hurricanes is sponsored by Kroger. Kroger, fresh for everyone. Air Team, your team, Air Team. And Carpet Giant. When you're ready to buy, come see the big guy, Carpet Giant.
Hello everyone, I'm Travis Herzog. Hurricane season is here. Ellington Airport plays an important role in how we understand, track, and predict hurricanes. Sometimes hurricane hunters fly from here to an approaching storm over the Gulf, gathering important data so that we can give you the most accurate forecast.
Legend has it that 80 years ago, a barroom dare in Bryan, Texas between American and British pilots resulted in the first flight into a hurricane, giving birth to the hurricane hunters. While this might be an embellishment of the truth, the fact is on July 27, 1943, Lieutenant Colonel Joe Duckworth twice flew an AT-6 Texan into the eye of a hurricane making landfall over Galveston. A year later, but entirely unrelated, the U.S. military began routine surveillance of hurricanes between North America and Europe. In these early days before the satellite era, the brave pilots were literally hunting for the hurricane's center as they blindly flew through the violent winds and rain. Even with their limited observations, we gained valuable insights that allowed forecasters to make better predictions.
Alicia is drifting very slowly.
Fast forward roughly 40 years, and another hurricane is making landfall over Galveston. It's August of 1983, and Hurricane Alicia is battering the island with 115-mile-per-hour winds. Hurricane hunters slicing through Alicia from above are using a new technology called tail Doppler radar to make the first 3D CAT scan of a major storm. This technology will lead to a major forecasting breakthrough 25 years later during another Galveston hurricane named Ike. But first, we look at what we've learned from Alicia.
Hurricane Alicia hit 40 years ago, but it is still fresh in Rebecca Langley's mind.
We lived out on the west end and there was only a couple of houses at the time, so we lived right on the water, so they were really worried because of the flooding. It actually had gotten all the way to the stilts, at the top of the stilts actually during the hurricane.
Hurricane Alicia formed in the Gulf south of New Orleans. 3 days later, it hit Galveston Island. Alicia rapidly strengthened to a Category 3 storm in the final 12 to 18 hours prior to making landfall. It was the first hurricane to strike the continental U.S. since Hurricane Allen made landfall near Brownsville, Texas 3 years earlier. Alicia was also the first storm Langley knew she realized she should have taken seriously.
We had, left the coast a few times as kids with the family for threats and everything, but we never had been through anything.
So this was your first
So it was
time.
the first time. So that's another reason I didn't take it seriously, because a lot of people think, oh, it'll just be a lot of rain and water, we'll be all right, but it was pretty crazy.
Langley was also about to be a first-time mother. She was 8 months pregnant with her son Eric and worried that Alicia would put her in the hospital early.
Everybody was boarding up, we boarded up, we came over here, we boarded up the house here, bunkered down, and then the hurricane started. I was a little worried. I thought I was going to go to UTMB first because I was thinking, I don't know if I should stay here during the storm. I did start to get worried at the last minute when it really got crazy. But then we went ahead and went in here and stayed. We thought we'd be good.
When Alicia hit, it proved to be the most significant test yet for the 15-foot-high seawall built in Galveston to prevent a repeat of the hurricane of 1900 that wiped out the city, killing at least 6,000 people. Patrolling the streets of Galveston the night Alicia hit was Galveston PD Patrol Officer David Smith.
At that time, the Galveston Police Department doubled up the shifts, had our officers come in and patrol the areas. The city of Galveston at that time did not order an evacuation of the main island. They did at the west end, but not the main island itself, behind the seawall. As a patrolman, we would patrol the areas, watch the businesses, help people as they would need assistance, maybe boarding up their properties and things like that and moving things to higher ground. But a majority of the islanders who have been through multiple storms have a strong will, and they have weathered these storms in the past, and probably about 75% of the islanders actually stayed on the island, even though there was never a call to evacuate the entire island, just the west end.
Alicia was a small and compact storm, but its winds were terrifying.
And you do not realize how terrifying those winds are until you sit there hour after hour and listen to that high-pitched howling of a sustained wind of 113 miles an hour. You begin to wonder if the building that you're currently in is going to be able to hold up to those high winds for so many hours. It actually grates against your nerves, that constant howling. And you pray for the end to come, for those winds to go away, which they finally did. That morning we went out when the sun came up, and it was just unbelievable the amount of damage on the seawall area and throughout the island.
The violent, destructive storm cost nearly $2 billion in damages and sadly would claim the lives of 21 people.
A lot of those deaths were due to falling trees, actually motor vehicle accidents, because you do have some people who will try to drive during these storms and something hits the car or they hit something themselves and there ends up being a fatality accident. Lightning strikes and power hits as well. As the hurricane's coming through, you lose your power lines begin to burst, and also your transformers begin to blow, and you see this arcing of blue in the sky, in the dark sky, and that's a result of the power loss situation. And unfortunately, a lot of people get electrocuted during these storms as well.
40 years later, Smith, now the executive director for the city of Galveston, says the city is well prepared for any major hurricane to hit the island.
Now there is massive planning done on these. We have procedures in place whether a storm comes or it does not come. We have financing in place in case the worst happens as well. So the situation now is much better than it was 40 years ago. The city of Galveston is well prepared for any major hurricane to come into the island and be able to bounce back quickly.
Lessons learned from storms like Alicia have shaped how building codes along the island have changed over the years.
So if you're building down here in the island or the Gulf Coast, there are strict guidelines you have to build by. Following those guidelines helps your house or your building stay together during even a major storm. So these changes in building codes and building policies and locations where we put things, following the FEMA guidelines in reference to the height of the buildings has helped dramatically. So during a major storm, I don't think we'll have as much devastation as we have had in the past because of our experience.
As Langley returns to the two-story home she braved during Alicia's wrath, the memories are still vivid. Her son Eric often asks about that night.
I've told him quite often about it, and he just calls me tough mom because I'm always tough. And so he says it started out with you and the hurricane with me. If we survived a hurricane, we can do the next ones or whatever comes along.
Tornadoes are difficult to spot in any storm. 22 formed during Alicia. We look into hurricanes and tornadoes, plus take you back to January 24th to see how new technology is saving lives when Eye on the Gulf Hunting Hurricanes returns.
Hurricanes are mostly known for their straight-line winds, but did you know some will produce tornadoes? 22 tornadoes formed during Alicia, 12 occurred right here in Harris County.
The strongest tornado was an F1, and it hit right here in Webster, Texas. That tornado, like most that are spawned by hurricanes, occur in the outer rain bands of the storm, sometimes as many as 100 miles from the eye.
Most tornadoes form in the hurricane's rain bands to the right of the center, or the dirty side of the storm. As the hurricane comes inland, the winds aloft continue to howl, while winds at the ground begin to slow down due to friction. That difference in wind speed with height is called wind shear, which gives tornadic thunderstorms their spin. Even after the eye wall passes, tornadoes can still form in the feeder bands on the right rear quadrant. Professor Nowatarski from the Meteorology Department at Texas A&M was given a government grant to study tropical tornadoes.
Within a hurricane, you've got strong winds, essentially, and the maximum winds in a hurricane are usually a couple hundred meters or maybe even a kilometer above the ground. So in that lowest layer, you're going from weaker winds at the ground to very strong winds. So you have, within the hurricane itself, the hurricane causes vertical wind shear, essentially.
There's a lot of tornadoes associated with this storm, and I'll give you some specific areas.
These tornadoes can be sneaky since they hit away from the core of the hurricane.
So when a hurricane is really mature and intense, often there's heavy cloud cover across the hurricane. But as it moves inland and weakens, you get breaks in that cloud cover that allows that sunlight to filter in and destabilize the environment around these rain bands. So you've got that shear and you've got that solar heating, and that's why often you can see these tornadoes persisting several days after landfall and thousands of miles in some cases from where the storm actually made landfall.
A perfect example of that is the violent F4 tornado that hit Galveston during Hurricane Carla in 1961. It formed in an outer rain band 12 hours after landfall of the eye and 165 miles from Carla's center, which was just west of Bastrop. It was one of the two strongest tornadoes ever produced by a hurricane, and its 8 fatalities made it the deadliest tornado in Southeast Texas history. In 1967, Hurricane Beulah produced a then record 115 tornadoes right here in Southeast Texas. And hurricane-produced tornadoes are often very hard to protect.
For tropical cyclone tornadoes, though, often they spin up very quickly. By the time you see the rotation on radar, if you even see a rotation on radar, the tornado's already ongoing.
On the afternoon of January 24th of this year, a powerful EF3 tornado with 140-mile-per-hour winds struck Pasadena and Deer Park. On the traditional radar display that shows rain and hail, it did look like it contained a powerful tornado. Even if you were outside, you couldn't see the tornado because it was heavily wrapped in rain.
Luckily, meteorologists here at the National Weather Service use a modern Doppler radar that can not only see rotating winds inside of a storm, but it can also see falling debris inside of that storm, a telltale sign that a tornado is actually on the ground.
About 10 or 15 years ago, we got an enhancement to our radar called dual polarization. And what that means is we can not only determine where the raindrops are or where the targets are, but also the shape of them. Now, what the correlation coefficient tells us is, are the targets the radar is hitting similar or are they different? And when you have high correlation, that means you're looking at mostly raindrops, maybe hailstones. But when you have low correlation in this scenario, you're seeing debris as well.
That new debris sensing technology was on full display during our last 2 devastating tornado events. The 140-mile-per-hour EF3 Onalaska tornado in 2020 and this year's Pasadena tornado.
There's a pretty tight circulation developing, likely indicating the presence of a tornado.
Chief Meteorologist Travis Herzog was on duty that day. He could clearly see the debris signature on our mega Doppler display.
They called it a radar-confirmed tornado because of 2 things. There was a very strong circulation detected on the radar that we almost always only see when there's a large tornado on the ground, and then you saw the debris. The correlation coefficient dropped out, and there was this perfect circle on the radar that's indicative of debris rotating around that circulation.
It was our first time we've ever issued a tornado emergency. These are very rare, and they're issued when you have a confirmed violent tornado moving through a heavily populated area like Southeast Harris County especially.
My heart literally sank. I'm thinking worst case scenario because in that language of the warning, it said a confirmed extremely large and dangerous tornado is on the ground in Pasadena. And we've thought ever since the Channel View tornado in 1992 that it was only a matter of time before we saw a repeat of that type of tornado, which was an F4. And at this time, I'm thinking, is this potentially another F4 tornado? All the ingredients were in place that day to create tornadoes F3, F4 in Southeast Texas.
The most useful tool for spotting tornadoes is the human eye. The National Weather Service has been using firemen, policemen, and ordinary volunteers to spot tornadoes.
Get my camera on it! It's on it! Hey,
and then there's these guys.
Oh my God! They went to someone's house.
People have been chasing tornadoes since the 1960s. Now, on any given tornado day, hundreds of chasers hit the road to spot or chase tornadoes for scientific research, to help warn the public, or just for the thrill of it.
We are looking at a wall cloud that just produced a confirmed tornado.
Even I have gotten out on occasion to chase, and I've been doing it since the late 1980s. Hopefully, all of our efforts to analyze and spot the dangerous storms will help save lives in the future.
Hurricane Ike was a very dangerous storm. We take you back to the wrath of Ike and how advancements to the hurricane hunters helped explain the dangers when Eye on the Gulf Hunting Hurricanes returns. Hurricane hunter flights give us crucial details about a storm's strength and structure that we cannot obtain any other way. In fact, there are actually two different branches of hurricane hunters, one from the Air Force, the other from NOAA, and they fly 3 different types of planes to carry out specific missions. This C-130 is one of 10 operated by the Air Force branch of the hurricane hunters, and it's a real workhorse. While in the air, the C-130 mission is clear: gather data and find the center of the storm. The other 2 types of planes are more research-focused. The Gulfstream 4 jet, nicknamed Gonzo, flies high-altitude missions to sample the steering currents ahead of an approaching hurricane. Data from instruments dropped 40,000 feet above the water help our computer models better predict where the storm will go. The P-3 is a flying laboratory unlike any on planet Earth, operated by the NOAA branch of the hurricane hunters. There are 2 of these planes, nicknamed Kermit and Miss Piggy, each with the radar in its nose, belly, and tail. The tail houses the Doppler radar, which gives us the clearest picture of a storm structure.
Nowadays, it's like the cat scan. We fly through the storm and we have a full 3D picture right after it comes through.
Doug Brown and I are here, and we're going to show you, we've just gotten the latest coordinates on Hurricane Alicia.
That would be the location right there. And in terms of latitude and longitude, 29.5 north is the latitude.
Back in 1983, during Alicia, there was no way to remotely get that data off the plane. It was recorded onto physical tapes. And even if we could have remotely sent it back to land, the computers weren't powerful enough to process it. 25 years later, all the technology was in place to take the tail Doppler radar data from Ike and send it in real time to a supercomputer at the University of Texas. When the forecast it created was compared to what Ike actually did, the results were stunning.
It was giving superior tracking intensity forecasts. And because of that, all of a sudden NOAA said, okay, we'll have to do that. Because, you know, if the researchers are doing it, we're not going to let them best us. We're going to do it too.
These recon flights also revealed Ike's massive size, 10 times bigger than Alicia and heading towards Galveston.
15 years ago, residents of the Bolivar Peninsula were preparing for yet another hurricane season, but nothing could have prepared them for the devastating hurricane that would roll through that September.
I mean, it was crazy. It was like an atomic bomb had hit down here. It was devastating.
Plans were made, but nothing could have prepared them for what was to come.
But the storm has come, so we'll go down and board your house. You know, we came down on, I guess, Wednesday and boarded up the windows. They had never been boarded before. They had the boards, but never put them up. And we got out of here at 4 o'clock on Thursday, okay? And I'll tell you, people that tried to get out at 9 o'clock on Thursday, they got stuck. They had to swim out. Because when you leave here down towards 87, towards Winning, you'll see where the road is not that high and the water had come over the road. It was impassable.
Even though Ike was a Category 2 hurricane, its massive size produced a catastrophic storm surge. When Ike slammed into the Bolivar Peninsula, the massive storm surge ripped apart many homes. Parts of the peninsula were now just a mass of sand and storm debris.
The only thing we found were the concrete slab upside down. The rest of it was gone. There wasn't a thing left of that house. We would later find the house about a mile away. In subsequent visits to the beach, we would find parts of his railing, the blue railing that we had painted. That was all we ever found.
When L.B. Hunt returned, he had trouble finding his home.
Beaumont Drive, everything on the right side, everything's gone. Those were older houses, older structures, and so on. On my side, almost everything's gone. Our house was gone. It was a one-story, and it sat about 16 feet off of the land level. And what was left of it was about a third of the sun deck. It sat on 24 pilings. 22 pilings were left, and that was it. You walked around and you just kept looking. As if you've looked long enough, you would spot something you recognize.
Parts of the Bolivar Peninsula were left devastated, which led people to ask, what can we do?
13, 14 years ago, it was like an evolution with the windstorm engineers and engineering requirements. We were building more to about 120 to 130 miles an hour in the beginning. Today, we're building to 150 mile an hour engineering. But we always use a 12 by 12, and over the years, they've gotten deeper and deeper in the ground from the engineer requirements.
But could something bigger be done? This is where the plan of the Ike Dike comes in. The Ike Dike plan includes a long coastal spine that stretches from the Bolivar Peninsula along the entirety of Galveston Island. It includes floating gates across Galveston Bay that can close as water rises during a storm. This would protect the refineries and factories from storm surge.
I think it's going to be good. Right now, we're at the mercy of the highway and the ferry. I don't know whether you've driven down the highway, but it's fragile. And I think about 3 to 4 days before landfall is your minimum to get out of here, either direction. So, yeah, the Ike Dike would help tremendously. I think it really would. So, I'm all for it and been for it since I've heard about it.
But some residents have their reservations.
People come from all over the world to Bolivar Peninsula to birdwatch this time of year. In migration and mating season, they flock literally down here to watch that. And, you know, so that's a big question. What is that dike wall going to do to the bird sanctuaries? Some of the area they're talking about putting that as federally funded, you know, sanctuary land where they, you know, how are they going to get around those requirements? The other thing to me is environmental impact as far as natural drainage and everything else from the bay. Turtle nesting every year is an issue down here. So, you know, all those things need to be accounted for.
But what makes this stretch of coastline so susceptible to storm surge?
Well, the continental shelf and the Gulf Coast, much of the Gulf Coast is very shallow and very, very broad, so that just exacerbates the risk of storm surge in that area where that water piles up. It can pile up much higher. It can go farther inland along portions of the Gulf Coast. So that's one susceptible factor. The sort of the shape of the coast allows water to pile up from a sort of a southeast or easterly direction and sort of focus in on the parts of the Texas coast as well.
And unfortunately, research from NOAA shows our sea levels are rising.
You're raising the water levels, and then therefore you're probably going to, with any storm, you know, push water further inland, more so than you have before. So you might have flooding in areas that you might not really experience. Just by changing that water level, it really changes the landscape of which, you know, what areas can get flooded and what haven't.
And even though the view is beautiful, the residents of the Bolivar Peninsula know the risks of coastal life.
There's about 3 things I don't like about living down here, and that's August, September, and first part of October, because you worry about it every year. You know, you think about, well, how am I going to pack my stuff? Where am I going to put it? What am I going to find if we have another Ike down here? So, yeah, it's something that's always in your mind.
While the beach and the Gulf Coast and the ocean is just this beautiful mistress, she's a killer. She is a killer. Don't ever doubt it.
Eye on the Gulf, Hunting Hurricanes is sponsored by Kroger. Kroger, fresh for everyone. Air Team, your team, Air Team. And Carpet Giant. When you're ready to buy, come see the big guy, Carpet Giant.
Since 2017, we've seen 23 major hurricanes in the Atlantic Ocean, from Hurricane Harvey that left historic flooding here in Houston to Hurricane Ian just last year. Now, we've seen so many powerful storms over the last few years because of the lack of an El Nino. Now, an El Nino, it's a phenomenon all the way in the Pacific Ocean, but it has the power to control the jet stream over the Atlantic and the Gulf. It creates stronger, more volatile winds, which actually decreases the chance for hurricane development. The flip side is the La Nina. Winds in the upper and lower atmosphere weaken and are calmer, more uniform in the Atlantic and Gulf. This cuts down on that wind shear factor, so hurricanes can develop, grow, and intensify quickly. And we've been in a La Nina pattern since 2020, and we've had the opportunity to see more hurricanes because of it. But the important thing is we are currently transitioning from a La Nina to an El Nino. First time this has happened since 2015. Fun fact, based on records going back to 1950, not a single hurricane made landfall in Texas during a summer El Nino. But that doesn't mean we're off the hook, as Tropical Storm Bill proved in 2015, making landfall just west of Matagorda Bay and dropped over a foot of rain 60 miles southwest of Houston. So just because it hasn't happened before doesn't mean it won't. That's why the ABC13 weather team wants you to have a hurricane plan for you and your family, because it only takes one storm.
Hurricane Ian was one of those storms. It's the deadliest hurricane to hit Florida since the Great Labor Day Hurricane of 1935. The high death toll may lead you to believe residents were caught off guard. But the forecasts for Ian were incredibly accurate from the get-go.
In the last few years, the data from all these aircraft are going into the forecast models, and they're improving the track and the intensity forecast from the models that we then use to make our forecast by 10 to 20%.
Over each of the last 3 hurricane seasons, we've seen a tropical storm rapidly intensify into a Category 4 hurricane just before making landfall along the Gulf Coast. And in each of those storms, Laura, Ida, and Ian, the forecasts from the National Hurricane Center were almost perfect for both track and intensity.
Dramatic change in how we do things due to a lot of good research here at NOAA.
Dr. Frank Marks is the head of NOAA's Hurricane Research Division. He's been conducting research flights into hurricanes for over 40 years. But there's still one part of the hurricane where we have very little data because it's simply unsafe to fly: the lowest 2,000 feet. Only one Hurricane Hunter mission has flown into the lowest level of a Category 5 hurricane, and it was because a radar malfunction led the crew to believe it was a much weaker storm. Dr. Marks was on that terrifying flight into Hugo in 1989.
And we're thinking, oh, this is going to be a piece of cake. And then all of a sudden the wind started climbing rather rapidly in like the last 2 minutes of approach. And I looked at the pilots and I said, you know, maybe we ought to go up. No, I think we're okay. Let's see what happens. Well, we saw what happened.
In a matter of seconds, the plane was violently tossed up at over 5 times the force of gravity and then back down at almost 4 times the force of gravity. They struggled to break through the eye wall's 185-mile-per-hour winds and into the calmer eye.
And just about as we broke through the last bump, somebody in the back said, there's a flame coming out of engine number 3.
Thankfully, they made it out alive. And now it's standard practice to only fly into hurricanes at an altitude of at least 10,000 feet. Researchers are now turning to drones to go where it's simply not safe for humans. The last research flight made into Hurricane Ian encountered severe turbulence when the storm was near Category 5 strength. But once they punched into the calmer eye, they made history by launching a new drone called Altius into the eye wall.
And it flew for almost 2 hours, recorded winds over 200 miles an hour, so incredible success story. And what's lost in all of that is just the amount of work that went into that one drop, and it happened to be in that perfect storm.
As the Hurricane Hunter missions continue to deepen our understanding of how hurricanes evolve over time, our forecast here in the ABC13 Weather Center will only get better. Forecast accuracy is now more important than ever, as we've seen a recent explosion of Category 4 and 5 hurricanes making landfall along the Gulf Coast.
We know that any tropical storm or hurricane that makes landfall along the upper Texas coast is going to be a problem. But the nightmare scenario is a Cat 4 or 5 storm making landfall right here in southeast Texas. The kind of storm that isn't just an inconvenience, it's life-altering. And those kinds of storms seem to be coming increasingly frequently right here along the Gulf of Mexico.
Hurricane Ian, Ida, Laura, and Delta. All Category 4 hurricanes in the Gulf, all of them made landfall just over the past 3 hurricane seasons. That is a remarkable number of devastating storms in the Gulf of Mexico.
You do need to check back regularly with the forecast.
And Daniel Brown, senior hurricane specialist with the National Hurricane Center, is taking notice.
We've had more Category 4 and 5 storms make landfall in the U.S. since 2016 than we did from 1963 to that 2016 period.
And while some of that can be attributed to cyclical trends, we do know that warm water is fuel for hurricanes, and the Gulf is warming at an alarming rate. Sea surface temperatures in the Gulf of Mexico are warming at twice the rate of the ocean in general. And those warm waters along our coastline are a problem. It can turn a lower-end storm into a buzzsaw in just a matter of hours. like what we saw from Hurricane Delta in 2020, going from just a tropical depression to a Category 4 hurricane in just over 36 hours. That rapid intensification not only leads to higher-end storms making landfall, but it also cuts down on our time to prepare for a storm.
We've seen these storms rapidly strengthen in the couple days before landfall, which is concerning for folks because you don't always get that 5 days notice when a hurricane is threatening.
Now, this is a well-known and well-documented problem, but a recent study suggests climate change is not just making the waters warmer, strengthening storms, it's also bringing more storms into the Gulf. A 1-2 punch that could have deadly consequences.
The study found that warming waters are changing the wind flow patterns over the Atlantic, and that the overall steering winds in the western Atlantic are shifting farther westward. So why does that matter to us? Well, the westward shift has and will continue to steer hurricanes closer to the U.S. coast, increasing the frequency of landfalling hurricanes in a given year. So how can we keep up with storms that are expected to be both more intense and more likely to come ashore?
3, 2.
With new technology to help us analyze storms faster than ever and make forecasts more accurate than ever. In May, just prior to the start of the 2023 hurricane season, the National Hurricane Center got a brand new tool in its arsenal. A series of 4 satellites launched into low Earth orbit named Tropics. Those satellites will work together to bring us observations on the precipitation, temperature, and humidity of storms every single hour, data which was previously available only every 6 hours. That more frequent data will help meteorologists to better understand the increasingly rapid changes that occur within a storm, and help the National Hurricane Center improve their prediction and forecasting models. The end goal is to just give people more time to prepare. And as Daniel Brown explains, that last part is on you.
We're back at the Hurricane Center forecasting these storms, trying to tell where they're going to go, how strong they're going to be, and then you have to do your part, is to get your supplies, have your plan, know what you're going to do.
If you need a little refresher on how to prepare for hurricane season, just head to ABC13.com. While this does appear to be a less active season than the last few years, you must stay ready because it takes just one storm. The ABC 13 weather team will keep our eyes on the Gulf this season to help you get through it. I'm Travis Herzog. Thanks for watching.